It must be very unusual for you to see a person like me. I'm a foreigner. Obviously, I'm not Chinese, but I'm the only non-Chinese president in the company. And perhaps one of the reasons that I have this position is because the company trusts Paul. They don't trust me to say things that they want me to say. They trust me because I say the right things. And I think that's very important to understand. I have no brief here. Before I came here, I know the situation in Poland, US, of course, I travel everywhere. I meet all presidents, prime ministers, governments, everywhere. I don't have a script. I'm not told what to say. So what I've chosen to say is something that I presented a few months ago in UK. And as a result of what I presented, we had about 20 million people view this and give me a lot of positive feedback and ideas. I come to Poland perhaps once, twice every year for the last perhaps 5 or 6 years, usually to talk about innovation. And when I was asked to come here, I was really asked to focus on one thing, and that's really about what can 5G really do. So the presentation is called, I hope, I can't see exactly where, but the presentation is really called about trust. It's up on this side here, I think, yeah? But before I start about this topic, I thought we'd talk about just 5 simple things. And they're the components that I'm calling, let's trust this thing called 5G. The first one is about electromagnetic radiation. I know the situation here in Poland. I understand the situation in Western Europe and the rest of the world. But I thought it would be nice to bust this myth, okay? Poland is a very technical country, if I may say. That means you're very well educated in a lot of technologies. You actually understand this stuff very, very well, so I'm not going to harp on it, and I know the direction that you're moving. But the first point I mentioned yesterday in the panel is, let's talk about the truth, and let's base everything on facts. So a couple of facts. The only definitive study which the whole world has been using is almost 20 plus years out of date. All right? It was done, commissioned by a school because of the fear of a cell tower being located very close to the school. And the results are definitive. If you have a rat's or a mouse's brain and you subject it to EMF, it becomes cancerous. But the study did not include skin, the skull, the distances. It did not include these things because that wasn't the nature of the test. The most recent test, which is done by the World Health Organization, which I believe we should be able to trust, demonstrates that there is no correlation between EMF as we define it, as we use it in cellular technology. And I'm not going to harp on this. Don't believe Paul. Speak to the experts. Okay? Speak to the experts rather than hearsay. So first thing, let's talk about facts. Let's bring ourselves up to date. Let's not use 20-year-old data that perhaps wasn't rigorous. The second one, let's talk about security. There's 3 topics that are hot in Europe, yes? Obviously the virus. The second one, of course, is security. And the third one is about energy. Green, 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 right? You want to save the planet? You better do stuff now. We should have done it 20 years ago. It's okay, let's hope we are still in time. So let's talk about security. Let's bust the second myth. 5G is more secure than 4G. That's it. Every time you turn on your handset, every time you turn on your 4G or 3 or 2G, they're worse. A university student can write the software on a simple laptop with simple off-the-shelf products, and he can identify who you are and where you are. It takes him about a week of software programming. In certain countries, they do this to steal your ID so they can crack your passwords, predominantly for your credit cards. You can imagine if this is so pervasive, pretty much anybody with enough money can monitor all the 4G networks and 3G networks and 2G networks. There's no security. What did we do in 5G? The 3GPP, it's a standards body with ETSI. I think you know the European ETSI, yes? Together with about 26 telecommunication companies and governments, decided to fix this problem. So we encrypt all the data when the telephone is turned on and during conversations, and we tunnel it through. So it doesn't matter whether it's a Huawei base station or another vendor's base station or anybody's base station. You cannot identify the user ID, location, and information. That's the first thing we did with 5G, those two things. We encrypt it, 256. A quantum computer will not crack that. And we provide a secure socket layer all the way through the network. The second thing we did in 5G from security perspective, we understood that there would be industry benefits from 5G. What's the best way to provide and support that type of service for different industry, for different type of sectors, based on different type of requirements? We slice the network, however you understand slicing. It's a little bit like an MPLS. It's a little bit like VPNs, if you want to think of it in simple fashion. We never did this in 4G or 3G. We never did this in 3 or 4G. So we had to think about security at the service layer in 5G. That's fundamental differences between 4G and 5G. Enhanced interconnection security between mobile operators for roaming, for example. Increased authentication and obviously better privacy protection. We never talk about this when we talk about security, right? In 5G. 5G, security, security. It's far more secure. There are even reports that talk about the IoT and 5G going from thousands or hundreds of thousands or millions of people connected to billions of things, and the threat landscape will get larger. The landscape is bigger, but let's just go back to my first story. Everything connected on 5G is encrypted. So your water bottle, your cup, your tie pin, your badge, your wearable devices, they are secured all the way down. And they are secured all the way at the back because of the service layer protection that we put in. So where's the problem? This is the problem. You have multiple vendors down here, different operational models, and you have thousands, if not 2.7 million applications. There are no standards for the APIs. Certainly nobody's talking about security or data models in APIs. Nobody's talking at the IoT level, whether it's Zigbee or Z-Wave or Sigfox, LoRa, in IoT or Wi-Fi based networks or simple Bluetooth networks, are they? Nobody addresses this. This is where our problem is. I mentioned it yesterday in the panel. You download any app and it says it in black and white using different words, but can I have your data? And you say yes. Just now I want to connect to the Wi-Fi hotspot here. What does it ask me for? Your name, your age, your gender. Okay, I can understand name. Why my gender and why my age, for example, to connect to a Wi-Fi network? This is a shared responsibility problem. This is an end-to-end supply chain management problem. This is why it's appropriate we do talk about security. And yesterday I mentioned about education. Why is education so important? It's important. Just now you mentioned about all the SMEs here in the large SME sector that you have in Poland. It's very important to have the right dialogue, not to have opinions. Let's start with the facts. Educate everybody properly. Then bring in legislation, or if you want regulation or innovation, to try to bring about a shared responsibility in the 5G, because 5G is about transformation. And that brings me to the next point. So this is an example of all the security improvements that we've done between 4 and 5G. Perhaps you'll ask yourself the question, then why are certain administrations worried about 5G? That's a different discussion. So, what's the first use case for 5G? When you think about 5G, what's the first thing that comes to your mind? The word begins with F. It's a longer word, right? It's faster, right? It's the first thing everybody tells you. 5G is faster. Yeah. Lower latency, more connections, right? I would argue 5G has nothing to do with that. It's all about industry transformation. It's all about money. So I'm going to start with a couple of industry applications and give you examples. This information comes from third-party research data that was commissioned. And it's done by a UK company called STL. In the top, they're showing the benefit 5G has to different industry sectors. And I'd like to just give you two simple examples today, and then I'll take you through some use cases. And I'll define the opportunity, and I'll describe some of the problems in trying to achieve these types of targets. The first one is about manufacturing. Why do you want to deploy 5G in a manufacturing industry? Don't ask Paul. Don't ask the consulting company. Don't ask the telecom company. Let's go and talk to the 50 top manufacturing companies and their executives in Europe, in Latin America, and in Asia. And let's ask them two simple questions. Do you understand 5G? Never heard of it, don't know what it is. Okay, we don't need to ask question number two. But in the manufacturing sector, more than 90% of the CXOs of manufacturing companies in the 4 continents I mentioned said, I understand 5G. And the second question, what do you expect it to do? Here's what I expect it to do for me in my industry. And today, manufacturing is largely a serial process. If we look 150 years ago, worker A did something, passed it to worker B, passed it to worker C, etc., right? What happens today in a manufacturing plant? Robot A does something, passes it to robot B, passes to robot C, right? So here's two things that 5G can do. Today we have a conference facility here, and we'll have several hundred people. At the end of the day, this facility is a manufacturing plant, because we have deployed 5G small cells here. Robots from 6 different manufacturers are going to come in here. We're going to present them with the algorithm and the material. They're going to reassemble things according to their AI algorithm. It's not going to no longer be a linear process. That means any facility could be a manufacturing plant. It's not a serial process anymore. Today you put some plastic and say, make me a cup. And they will organize themselves to make the cup better than you or I could think of in our linear process. Think about what that'll do in supply chain globally. That's not quite today. We're experimenting with this, with Kawasaki, with ABB, and different manufacturers of these robots. But today, the single biggest problem is preventive and predictive maintenance. And the CEO said, today I have between 2 and 5 sensors per robot. I expect with 5G to have 10 to hundreds of sensors. And if I can collect that data, I can improve predictive maintenance by 1%. This is a 1% improvement. 94 billion, 25 billion, 200 billion, 23 billion, 28 billion, 351 billion. Just by fixing one small thing. Latency and lots of connections. Indoors. Why is this hard to do? Let's have a think about the SLAs and the targets of the telecom operators. They pay money for license. They pay money to vendors to build a network. They build towers. They sell SIMs. That doesn't sound like understanding the business of predictive maintenance or robotics, does it? Where's the biggest problem? Indoor coverage. 80% of all data is indoors. Where's your worst experience? Indoors, right? Let's have a look at the UK. Of the 10 cities that 4 operators are launching 5G, none of them correlate with those cities and towns that have the manufacturing plants. So the opportunities is hundreds of billions of dollars in an industry sector that is transformative, that will have downstream effects on all other industries and all society. You talk about operational efficiency, that's what it does. Can you see that the SLAs, the mindset between the traditional telecom companies and the industries that we want to transform using this platform called 5G and AI, by the way, will be very difficult. Let's take a second low-hanging fruit, and it's called health. Why do we want to use anything in health? Why do we want to improve it? Because it saves lives and improves quality of life, and that's probably the biggest topic in the world today, right? So here are 3 examples. One of them is remote patient monitoring. The second one is about virtual consultancy. And the third one is a thing called connected ambulance. I put that one in because it's quite topical, particularly in the UK and in Germany. Now you might say, yes, I can use my mobile phone today on 4G to have a virtual consultation with a doctor. But do you know what the problem is? You're competing with little Johnny, the boy next door, playing a video game. You get my message, yeah? When we do it in 5G, we'll allocate a slice of the network which will be reserved for manufacturing or for health or for gaming. You see the problem? See the opportunity? Let's talk about a connected ambulance. The concept of a connected ambulance is a sophisticated, rapid unit. It has very sophisticated technology in it, high-speed broadband and low latency, so that life-saving things can be done from within the ambulance. Concept is great. Doesn't make any money, but it saves a lot of lives. So politically, it's wonderful. I don't know Poland very well. I haven't traveled around on all your roads between all the cities. But if it's like, let's say, the UK or Australia, I don't know about here, but does your phone drop out on any of the major roads? The answer is probably yes. And now you expect this high-powered, low-latency, broadband 5G on the M roads, A road, B road, or C road to be available 99.9% of the time? It's not going to happen, right? And the reason it doesn't happen, again, is coming back to the SLA. Build a site, sell SIMs, cover 95% of the population. Nobody said that every road must have high-speed, low-latency connectivity. You want autonomous vehicles. It's not going to happen very quickly and not pervasively unless you understand how to deploy this. So these are deployment problems. They have huge benefits to society. Look at the numbers in healthcare. It's the biggest industry after manufacturing and the biggest opportunity, but the most complex. And this can't be done by a telecom operator or by a government or a regulator. This has to be done across industry, different industry partners working together to solve the problem. Let's talk about this one, which is a favorite of mine. I did it on the back of an envelope during a cup of coffee with a friend. My estimate is 33.8 with 9 zeros kilowatt hours per year. So I asked somebody to do it a bit more rigorously. Yeah? The bottom line, I'll take it step by step to explain why. If you deploy 4G, so this is an example, the red line. If you deploy the best 4G technology on all the spectrum you have, 700, 850, 900, 18, 21, 26. You have 10 megahertz here, 5, 20, 15. You pull it all together, you deploy the best 4T, 4R technology, 4G. You have a limit. This is actually done for Europe, so this includes Poland. Now let's look at the European growth curve of data consumption out to about year 2025. What happens when the growth hits the capacity limitation? You need to build more sites. What's the biggest problem for a telecom operator today? Site. Where to find the site, how to acquire the site, how to operate the site, how to get the power to the site, how to provide backhaul to the site. But if you deployed 5G, you start with something that has 20 times more capacity. 20 times more capacity as a minimum. So the first one, if I can go back, can I go back? Yes. The first one is 5G is cheaper than 4G. Because if you have to visit the site to put in something that has 1/20th of the capacity but consumes the same power, weighs about the same, costs the same, you can see you're deploying the wrong technology for the wrong purpose. So first rule, 5G is cheaper than 4G. If you have growth. If you have no growth, you don't need to invest, so you don't care. Let's look at the operating costs of a typical company. Roughly 60 to 62, 65% for every telecom operator in the world, more or less fits this. It's called operating costs, OPEX, not the CAPEX. Let's look at the radio, this 5G thing. It's the one that's got 12% in blue. It's a one-off cost. It's insignificant. The biggest challenge is site rental. The second biggest challenge is the backhaul, getting the signal back. And the third one that goes on forever is power, electricity, 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 right? We talk about building wind farms, we talk about building solar farms, nuclear power. If we reduce consumption, you have to build less, right? So if we can figure out a way to consume less, the airline industry is under a lot of pressure. You see it in the news perhaps once a week to reduce carbon emissions. It's roughly 2 to 3% of the global CO2 levels. So here's why you should do 5G. This is based on 12 to 18-month-old technology, based on a Huawei particular product. You have a look at the deployment on the left. The left is really complex, right? Even to an engineer, you can see that's a typical mobile site. Do you see the things on the right-hand side? I don't want to say too much about China, but this is how we deploy 5G in China. We're not interested in the things on the left-hand side. We build them using lampposts. We build them using shared infrastructure, shared facilities. You can do this in Poland now. And why do you want to put it in a lamppost? Because the power is there. There's probably a duct for the backhaul. And the site probably, you can, because it's part of a government, regulate the cost. And they're the three biggest problems that the telecom operator has, right? And if you want the downstream benefits of connectivity based on massive connections and low latency on infrastructure like transport, which is the third biggest one after energy, manufacturing, and health, then you need the infrastructure to be very, very common, very simple. So we can see, you can see the difference between 4G and 5G in terms of efficiency. So why do we have 2G and 3G networks and 4G networks? 4G perhaps we can just keep for the moment, but the 2 and 3G networks, in Poland you have about, not quite, almost 20 million subscribers still using 2 and 3G. How inefficient do you think they are? How much extra energy are you consuming from the planet? So I asked them to go a step further. And this is perhaps the best tagline I can think of. After 5G is cheaper than 4G, yeah? And 5G is more secure than 4G. And that's that if you continue to build 4G networks, and of course it means 3 or 2, you double the carbon footprint of the planet. Yeah? And if you deploy 5G, you can see we go roughly from about 300 million tons of CO2 per year to a little bit higher, but then it starts to drop off in 2025. This was based on the average of the industry's 5G equipment. I'll say a second little point about Huawei. A few weeks ago in London, we launched a new product. The 5G consumes similar power consumption to the 4G. So this graph just gets better. I think that's a pretty good reason to deploy 5G. Yeah? Now, Richard asked me to talk about more services in 5G and what can we do. So I thought I'd bring up here a few examples, and I'm calling it about trusting digital systems, because 5G by itself does not do everything or even anything. But if you want the benefits of 5G, you need to connect everything. You need to pull the data into a cloud or another base system, and then you need to apply AI. And what I believe the opportunity for Poland is, as I propose to the US, deploy the best 5G technology, collect all the data, and then analyze it, because that's what Poland's good at. Data scientists, you're very clever in this area. And I would argue the AI capabilities of Google and others in the US are also very, very good. That's where you transform industries. That's how you grow economies. I'm not going to talk too much about robotic surgery, but I'll give you a practical example that we did in China over several hundred kilometers. It's tele or remote medical analysis, diagnosis. We're using an ultrasound device. Ultrasound devices cost between 10 and hundreds of thousands of dollars, depending upon the make and the model. And they usually require a skilled technician and for you to come to there, put it on and analyze using ultrasound. So we did an example here in Luohu. It's a small suburb, and the company is called Luohu Health. And they invented a distributed ultrasound unit. So the technician sits in his office with a small device and a hand phone, or a tablet or a computer. And several hundred kilometers away is the patient with another unit that just attaches to the abdomen. And as he's pushing here, this thing here moves. It presses and moves around. Yeah? Nothing really fancy there. But here's the catch. If the latency is not low enough end to end, by the time the technician pushes here and gets feedback, this has penetrated the abdomen. I think you agree that's not a good scenario, right? So we were calculating whether 5G would be a suitable technology here. We can't fix the backhaul. The backhaul, fixed milliseconds, it's already fiber. But the difference between a couple of milliseconds in 5G, or half a millisecond in 5G, and 30 to 50 milliseconds in 4G is sufficient to make this use case viable or not viable. It's an end-to-end problem. It's thinking about health in a different way. Let's talk about VR and AR. All the hype is about AR and VR, right? Have you bought a VR game recently? Or VR goggles? There's lots of them out there. They cost a fair bit of money, right? That's not a problem. Not really. But where do you use them? Outside cycling? Or indoors? You use them indoors. What was the biggest problem I mentioned in slide 2? 80% of all data is indoor. It's generally Wi-Fi, right? Do you know the difference between a Wi-Fi chip and a 5G chip? It's about $150 US. You imagine putting a 5G chip inside a VR glass. How much will the VR glasses cost you if the bill of materials goes up by $150? Second point, you're going to use this 5G goggle indoor where there's, no 5G coverage. Doesn't make too much sense, right? So you can see if you want to do VR for gaming and for these types of applications, you have to change the way behavior and the way operators deploy networks. The lowest hanging fruit for VR today, and AR very specifically, is in education. It's in the, I'll say not manufacturing, but related industries, where training is very costly and very difficult to do en masse. And that's probably the biggest opportunity here. Why didn't I put it in the first slide that shows the contribution to GDP? Because it's negligible, right? You might make a bit of money in B2C business and a little bit of money in B2B, but it's not going to transform an industry. I'd like to talk about aquatic agriculture. Poland, agriculture, 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 right? SME, SME, SME. Yeah. So this is a picture from Norway. It was a collaboration between Huawei, Telenor, and a few other third-party companies. We decided not to deploy 5G where the people are. Well, that's a revolution already. Let's deploy it along the coast. And let's not point it inwards, let's point it to the sea. Why? Because the second biggest industry in Norway is salmon farming, aquatic agriculture. Today, from the shoreline, they have a fiber optic cable that goes to a ship. From the ship, they have fiber optic cable that goes to each of these very large salmon farms. And they deploy cameras. And they remotely monitor pollution, temperature, fish, feeding, and other pollution. I call this facial recognition of the fish. Because what we do now is we put 5G from the land directly down to the pods. We can increase, because of the uplink, the quality of the cameras by definition. What's the benefit? We can detect precisely when the fish stop feeding. It saves about 20% on food. We save manpower about $150 million a year. And the last one is we detect parasites on the fish to improve productivity and gain by about 4%. And right now, yes, we are analyzing every single fish and their features to produce better quality fish so we can make more money, and I call that facial recognition of the fish. This is a great use case. It's a great example of an ecosystem of partners trying to achieve a result. How's my time going? 7 minutes. In the mining sector, one of the biggest costs is insurance. To insure the employees, because accidents happen in mines. So a smart person removes the people and puts in robotics, yes? And then you save a lot of operating costs. So these are examples in different countries and different cities around the world that have deployed private networks using 4G originally and now 5G because of lots of connections. Before it was just to monitor the diggers. Today, you can monitor everything about it because it's a remote robot. And all the diagnosis can be done anywhere. It doesn't even have to be done in the same country. Manufacturing I've already mentioned. I'm not going to go through every single use case. We won't have quite so much time to do all those. But I think you're getting the picture of where's the money. We had a very brief discussion this morning over breakfast, and I'm not aware of the situation precisely in Poland, but I understand agriculture is very well digitalized. So I haven't yet studied the benefits or what you could do further specifically in Poland. But I'll give you some anecdotes, since everybody yesterday was talking about anecdotes on stage. Before we had broadband, and I will mention a remote and rural area in China, that only had about 2,000 people living in it, so it's a very small village by any standard, even Chinese standard. And when they provided broadband there, that was one key platform enabler, and Alibaba, which is the e-commerce platform, came along at about the same time, the people in the village could continue to produce traditional products and now had all of China as a market and then obviously all of the world. So if you can connect the rural places, perhaps you can change the way we urbanize society and have people wanting to go back to different types of lifestyle because they can be very productive and very effective. They are fully connected. If you have a look at everybody, they're all looking at phones. Okay, you've all taken pictures and videos and you upload them, yes? So you're sharing examples, but these are examples where you can improve productivity, you can improve go-to-market. And the biggest challenge all, I'll say, SMEs have is go-to-market strategies. Now, why can't all that happen? And why hasn't it all happened? You know, 5G took 10 years, rapid development to get to standardization by 2017, October 2017. In February following year, 2019, we demonstrated and generally available products end to end. Handsets, fixed mobile products, radio, transport network, core networks. It was all available. So why haven't all these things happened? First one, education. A lot of scaremongering. People not understanding exactly what is this thing called 5G. It's faster, yeah? I mentioned it has nothing to do with speed. It's all about money. It's all about economics. It's a platform for transformation. It's a platform for security. So we need to talk about the facts. The second one is it's collaboration. And it's not collaboration within an industry or within an industry sector. Often you require collaboration across industry sectors because you have to figure out where the problem is, how to maximize the benefits. And one thing we don't do very well is collaborate, right? We all operate in silos. As much as we would like to, we generally operate in silos. We'll all come away from here, and the very next thing you'll do is go back to email and meetings, right? That's what we'll do. I'll do the same. The last one, second last one. It's about, and I mentioned this yesterday, do we regulate or do we innovate? Do we regulate or do we enable? I can remember a forum where one of the ministers from Africa stood up and said, I just want some help for somebody to tell me what is the right regulatory policy so I can grow my society. What a lovely question to have, yeah? Appropriate policies based on incentives. I was fortunate enough to be in a number of different countries. I'll give you them by example since it's published. The spectrum in Saudi Arabia is free for 5G, 100 megahertz each. Minister asked me, he said, maybe, Paul, I should make it 200 because I believe what you're saying. In Oman, the minister dropped the spectrum price by 90%. Within a month, he has a 5G network. Incentives, right? In Colombia, Ivan Duque and Sylvia largely agreed with concepts that we were suggesting to them. They reduced the capital price to 40% cash and 60% rural. Tell me how much? 0? No problem. 10,000 rural sites? License. Incentivize, incentivize. I'm not saying it's a bulletproof strategy, but you incentivize rather than regulate. It's probably a better way to do things. The last one, terribly difficult. I just gave you a simple example. After this presentation, the meeting, you'll all go home and emails and meetings, right? Talking about the things that are perhaps less important to society. You've got to think differently. You've got to think about shared responsibilities if you want security to be right. You've got to think differently about how to regulate things. You have to think differently about how much money you want to make. Do you want quarter-on-quarter earnings, or do you want to share? I've worked for Huawei for almost 12 years, and we have one very simple principle that we've always stuck by, and that's always about connectivity, because we believe if you can connect everybody, you will change people's lives. And we've demonstrated that throughout Africa and developing countries. We've demonstrated that throughout Europe. So I'd encourage you to think differently about how to do collaboration. Isn't it better we're all together rather than fighting and pushing everybody? You're in a unique position. You sit in a complex position, yes? Between East, West, and Russia and other places, yeah? It's a complex area you have here. But that doesn't mean it can't be done. Anyhow, I'm Paul Scanlan, and I think that's probably it. This is a program we put up called Tech for All. And the target is 500 million more people connected. And that doesn't mean necessarily in the capital city of Warsaw. It means all the people who aren't connected today, who don't have access to technology. And we just put in place some simple principles, visions, value systems, priorities. Yeah? Principle-centered leadership. And for those of you who'd like to know more about this company called Huawei, I'd be happy to answer any questions on the record as you choose. Thank you very much.